This is the area of a triangle, and I want to do this first. So you said if you had a right triangle here, and this was 6 and this was 8, what was the area of that triangle? Half the base times the height. Good. And area is 1/2 8 times 6. Okay? Now, what if I moved this here so that this is still 6? What's the area of this blue triangle? Is it different? It still has a base of 8 and still has a height of 6. Still area of, yeah, half the base times height. This is going to be what, 24? 4 times 6. Okay, what if I move this backward to here, and this height here is still 6? What's the area of this green triangle? Still 24? Yeah. What if I move it back to still a height of 6, but I go back to y zeta, center square y zeta, still a height of 6. Way back there is that height, is that area of that triangle still going to be 24? As long as that height is 6 and the base is 8, it doesn't matter where that goes. So that's something you want to remember, but we're going to take this a step further. We're going to say, well, what if we've got a side angle sandwich? In other words, what if this were 8, this were, I don't know, 6 again, and this were 20 degrees? Okay, how would you find the area of that? Well, what would you like to know? To find it, yeah, the height would be nice. The height would be nice. And so if you did SOHCAHTOA, the sine of 20 is h over 6. So then h is going to be 6 times the sine of 20. And then you have the height, you have the base, voila. So looking at this non-right triangle here, let's say we knew, I'm going to highlight the things that we knew. We knew C, we knew B, and we knew A, side angle sandwich again. We could find H, right? And the way we'd find H would be the sine of C is H over A, so H is A sine of C. So now the area of the triangle is half of the base, which is B, times the height, which is A sine of C. Now this is kind of a nice formula. If you rearrange it just a tad, it's 1/2 AB sine of C. Do you see all letters A, B, C represented? A and B are sides, C is the angle. We could come up with 2 more triangles where all 3 are represented. We could go AC times the sine of what? B. And we could do 1/2 BC times the sine of A. And all these are used to find the area of a triangle where we don't know the height, we know a side angle sandwich. So for this triangle here, the area is going to be 1/2 AB sine of C. So you have area of the triangle is 1/2 8 times 9 times the sine of 40. So you'll need to use your calculator, degree mode, because it knows degrees, and you'll get, what is that, 4 times 9 is 36 times the sine of 40. Could somebody give me that little calculation? I would guess it'll be less than 36, somewhere between, I would even think less than 18 maybe, units squared. Does this seem easy-ish? It's a formula. You could derive it. Did anybody get that? Just shout it out if you got it. But that sounds right. 23.4, you said. 1/4? Okay. 23.1. So that's the area of a triangle if you have two sides and an angle in between. One other situation you might have is one like this, where you have all sides. And this would be tricky because you don't know any of these angles. All you know are the three sides. If you knew the three sides, though, could you build this situation where you have let's call this C. Could you find angle C? How would we do that? Avery, how would you do that? Yeah, you can use log cosine. 7 squared, that's the side across from the angle, equals 5 squared plus 8 squared minus 2. 5 times 8. 2 times 5 times 8 times the cosine of C. And then you could do what you did before to find that. And then once you have C, you would go area is equal to AB 1/2 5 times 8 times the sine of what you found for C. That would be good. Now, there's a formula that you can prove by using log cosines and then eventually this area of a triangle that's called Hero's or Hero's formula. And this one is amazing. You can always do it this way, but you could also use this thing. We're going to come up with a partial sum, half the sum of the three sides. And this is something we'll use in the formula. The area is the square root. This is half of A plus B plus C. So in this case, it would be half of 20, which is 10. S times S minus A times S minus B times S minus C. No kidding. That has a nice rhythm to it. In this case, we're going to have S is equal to half of 7 plus 8 is 15 plus 5 is 20. S is equal to 10. So we'll have the square root of 10, 10 minus 5, 10 minus 7, 10 minus, what is that, 8. So this is going to be the square root of 10 times 5 times 3 times 2, which is 50, 100, square root of 300. Does that sound right? Units squared. Do you see how much easier this formula is? And you can certainly do it with the log cosines and then use the last formula. But I'll give you this on a test if you need it, but that's where it comes from. Oh, do you want to see a proof of it? Here it is with some blanks. You can do that if you want. I use this S equals half of the sum of the three sides, log cosine, solve for cosine C. This is something we're going to learn next unit. Sine squared plus cosine squared equals 1. You can solve for sine C. And then using all of this and a whole lot of algebra, you can get this final formula. I'm not going to do it, though. That's just for bonus if you want to give that a try. So I have three triangles, three formulas. Here is 1/2 B base times height, 1/2 AB sine C, and then Hero's formula with the S and the square root. This triangle right here, which one should I use? Should I use the purple, red, or green to find the area of this triangle? A, B, and the angle in between. Which one should I use? The red, yep. This is the 1/2 AB sine C. So I'm going to write that. Area equals 1/2 AB sine of C. Which one should I use for this one? This is the knowing only the sides. Which should I use, the purple or the green? Yeah, the green, yep. So this one you're going to use area is square root of S times S minus A, S minus B, S minus C. And of course, S is 1/2 of the sum of A plus B plus C. Okay, and then this last one, of course, is just going to be half the base times the height. Those are the three that you need to know. You need to recognize when you're going to use each one. I have one little challenger. I'm going to see what you can do with this. You have a diameter, goes through the center, 10, 10, and this length is 9. We want to find the area of the